Okay, given f of x equals 2x cubed minus 3x squared minus 11x plus 6, find all the zeros, all of them, and the complete factorization. All right, step 1. The degree of this polynomial, n, is equal to 3. That implies 3 complex roots, which means they can be real and or imaginary, but that includes their multiplicity. So if they count more than one multiplicity, you won't see as many as 3, but we shall move on to step 3 because we're skipping step 2. Step 3, rational roots. Okay, we're going to make the list of p over q, where the top will be the factors of the constant number, the constant coefficient 6, and the bottom of the fraction will be the factors of the lead coefficient 2. And then we'll put a plus and minus out in the front to account for all the plus and minuses, and we'll make this list, and then we'll refine it and come up with this final version of 1, 2, 3, 6, 1/2, and 3/2. Step 4, let's do the 5 steps in note 100 to find the bound. We take the absolute value of the 6, the absolute value of the negative 11, the absolute value of the negative 3. See, we're taking the absolute value of the coefficients but not the lead. We're moving backwards through the list. That's 6 plus 11 plus 3 equals 20. Step 2, we're taking the maximum between the number 1 and the result in step 1. The maximum between 1 and 20 is the number 20. Step 3, we're going to take the maximum of the absolute value of each of these guys in the list. So we have 6, 11, 3. The maximum there is 11. And then step 4, we're going to add that 11 from step 3 to the number 1 and get 12. And finally, step 5 is the bound m is equal to the minimum between the result from step 2, the number 20, and the result from step 4, the number 12. The minimum is the number 12. So that means that any real root that we find is going to live between negative 12 and 12. And I say that's not a lot of help, because if you look at our list, nothing gets that big. The biggest it gets to be is 6. So that felt like a waste of time. Let's move on to step 5, and let's do the test the rational roots. I really don't know where to start, so I'm just going to grab the first one in the list. Number 1, I'm going to synthetically divide by 1. So I list my coefficients in descending power: 2, negative 3, negative 11, and 6, and synthetically divide by 1. Bring down the number, multiply, add, bring down the number, multiply, add, multiply, add, and I'm hoping to get a 0 remainder, and I don't. Okay, let's move along to the next rational root possibility from the list in step 3. We'll synthetically divide by 2. That's the next number on the list. So list our coefficients, bring down the first number, multiply, add, multiply, add, multiply, add. No 0, didn't work again. Okay. Let's try 3. That's the next number on the list. Synthetically divide by 3. Bring down the first number, multiply, add, multiply, add, multiply. 0. Party time, party time. This means that we have a root of the polynomial, and that root is x equals 3. X equals 3 is a root. But I'm going to put a big cloud around this result because we've got lots of information in here that we're going to use. Big cloud around it. Okay. We're going to start our factorization. We're going to get it all the way down to first degree factors. That means inside the parentheses, the first power is what we want inside each parenthesis. Okay, and we're going to use the bottom row, which is the quotient and the remainder. Okay, so f of x equals x minus the root 3 that we found times the results on the bottom, 1 degree lower than the original third degree polynomial, is 2x squared plus 3x minus 2. You go, aha, we've got it down to a second degree factor, so we can try any kind of factor by guessing or whatever. I'm going to factor by guessing and see if I can get the roots that way and get down to the complete factorization. So we got f of x equals x minus 3 times 2x minus 1 times x plus 2, and that's by guessing. 2x minus 1 times x plus 2. Okay, so we need it in the form x minus the roots. That way we can just identify what the roots are, just pull them. So I'm gonna have to get rid of that 2 that's multiplying x inside the second parenthesis. I'll just factor that 2 out and bring it outside so I can see what the factorization looks like as x minus the roots. Okay, so if I just write f of x equals the first factor, x minus 3. Now pull the 2 out of the second factor, 2 times parenthesis x minus, let's see, 1/2. Yeah, that'll work. Times the x, well, x plus 2 is x minus a minus 2. Now, when I write it this way, it's super easy to see what the roots are. They're the numbers being subtracted from x. So the roots are in this list. They are the numbers 3, 1/2, and -2.